Hello everyone, this is Vasant, the 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a problem on holes in shear and bearing stress. So this is the problem over here. We already know that holes in shear and bearing stress has huge practical applications. This is one of such problem you can see over here. So there is a football stadium, upper deck of a football stadium is supported by braces. These are the braces. This is upper deck of the football stadium. This whole thing, this is upper deck of football stadium. And these are supported by braces. See these, you can see braces over here, right? These things. So this thing, this thing, this thing, these things are braces. Okay, these are braces. Okay. Upper deck are supported by the braces, each of which transfers a load P is equal to 700 kilonewton. Means from this brace, suppose if you consider this brace will transfer a load of P is equal to 700 kilometers to the base of a column. Matlab here, this is the column, right? If you see over here, this is the column. This is the column, right? Here it is the base, right? So this, if you see column over here, this column at the base, this brace is supported by something at the bottom, right? So you are transferring this 700 kilonewtons force from one base to the base of the column. This is the base of the column, and a cap plate at the bottom of the brace distributes the load P to four flanges. We'll see, first we seen what is upper disc. So the upper disc is supported by these braces, right? And each brace will transfer 700 kilonewtons to the base of a column, right? This is 700 kilonewtons, and this 700 kilonewtons is distributed to four flange plates. Let us move forward. So if you see this, and if you macroscopically see this in enlarged view, so this is the case. This brace is connected here. Okay, this is the brace. This is connected over here, and it is applying P is equals to 700 kilonewtons, right? So and here they provided a plate, cap plate, such that it will transfer load uniformly to four flanges available there. Where are the four flanges? See, this is the cap plate, this is the cap plate, and from this cap plate, see, this is the cap plate, and you have, these are four flanges. 1, 2, 3, 4. These four are flange plates. See, you can see over here also. These 1, 2, 3, 4 are flange plates. Okay. So this 700 kilonewtons is transferred to these four flange plates uniformly, means in equal distribution. So and from these flange plates are, see, cap plate to four flange plates through a pin, two gusset plates. So where are the gusset plates? These are gusset plates. 1, 2. These two are gusset plates. 1, 2. These two are gusset plates. Okay. I think you understand the problem. So now let us solve the problem. The first thing they ask is the average shear stress toe average in the pin. So let us solve first question. Sorry. Let us solve first question A. Toe average in the pin. First, let us understand the force distribution. See, from here we are getting 700 kilonewtons, right? These 700 kilonewtons are distributed. Suppose this is P, so this is distributed among four flange plates. Means this will create, this is P by 4. This will be P by 4. This will be P by 4. This will be P by 4. Okay. So here also, if you see, here it is P by 4, P by 4, P by 4, P by 4. P by 4, P by 4. Okay, this is the distribution of the force. We need to find out average shear stress in the pin. Where is the pin? Pin is this one. This whole thing is the pin. This is the pin. Okay. So in pin, if you consider the pin. This will be P by 4 from here, P by 4 from here, and P by 2 from here. So if you take any cross section in left or right, the force P, V will be shear force V will be P by 2, right? So the toe average will be V by A, that will be is equals to P by 2 into pi by 4 B square P, right? So toe average is equals to 2P divided by pi D square P. So toe average equals to what we got, 2P divided by pi D P square. What is the value of P? 700 kilonewtons. What is the value of diameter of pin? D pin, that is equals to 50 mm. So if you substitute these things, 2 into 700 to 10 cube divided by pi into 50 to 50. Let us put this in calculator. So 2 into 700 into 1000 divided by 50 divided by 50 divided by shift 5. So that is giving us, so average is equals to 178 point. Sorry, it is not P by 2 actually, it is P by 4, right? To consider any cross section, it is P by 4. So this 2 will get cancelled. So this 2 will be over here. So 2535 divided by 2. So divided by 2 will be 89.12 megapascals. Okay. See, this is P by 4. If you cut over here, if you take this cross section, cut over here, this is P by 4. And this is V. Then V will be equals to minus P by 4. We are talking in magnitude sense. Here it is P by 4. Okay. If you cut over here also, if you take this cross section, this body, the V will be like this. It also will be equals to V equals to P by 4. Okay. So this is about first part. The second part is the average bearing stress between the flange plates and the pin. So part B may first one, the average bearing stress between the flange plates and pin. What are flange plates? These are the flange plates, right? And this is the pin. So if you consider one flange plate, consider one flange plate, consider one flange plate. So that will be like this. And from this hole, the pin is passed, right? So if you take the contact area will be, suppose this is D pin and this is TF, thickness of the flange. Then contact area will be, projectional area of contact area will be TF into D pin, right? So sigma B is equals to PF, force in flange plate, divided by TF into D pin. So what is PF? PF is P by 4. What is TF? Value of that is TF into DP. Okay. Now let us put the values. This is 700 into 10 cube newtons divided by 4 into what is TF? TF value is 25 mm. So 25. What is D? D is 50 mm. So this is 50. So we will get, let us put the value in calculator, 700 into 1000 divided by 4 divided by 25 divided by 50. So we are getting 140 MPa. Okay. Now let us solve second part of the question. Second part of the question is bearing stress between the gusset plates and bearing stress between the gusset plates and the pin. So where are the gusset plates? Gusset plates are these things over here. These things over here. These are gusset plates, right? So if you take one gusset plate, gusset plates, from this hole is there, from that hole pin is passed, okay? So if you take the contact area, projection of contact area, will be is equals to T of gusset plate Tg into T of pin, right? And force in gusset plate is T by 2, right? So sigma bearing stress in gusset plate, here let us write sigma BF bearing stress in flange plates. So will be is equals to P divided by A. Here that P is P by 2. Let us write as F. So divided by area A. That area is Tg into D pin. So that will be is equals to P divided by 2 into Tg into D pin. Okay. Let us put the values. P is 700 kilonewtons. So 700 into 10 cube divided by 2 into Tg. Thickness of gusset plate. Thickness of gusset plate is 38 mm and D pin is 50, right? So let us put it in calculator. 700 into 1000 divided by 2 divided by 38 divided by 50. So that will give us 184.21 megapascals. So this is second part's answer. So sigma B G will be equals to 184.21 megapascals. इसका आंसर सिग्मा BF is equals to 140 MPa. First A part का आंसर तो average is equals to 89.12 MPa. Okay. With this we complete today's lecture. In next lecture we are going to solve one more problem on this topic. Until then, take care. Bye bye from 9pointer.